Hello friends, welcome to TEQIP GATE classes, an initiative by TEQIP Faculties. My name is Professor Vivek Singh Rathore and I am TEQIP faculty in Government Engineering College Bilaspur in Electronics and Telecommunication Department. Okay, so in this video lecture series, I am taking Signals and Systems subject for upcoming GATE examination, and till now I have taken 12 lectures completing classification of signals, and now I am in classification of systems, in which I have taken in last lecture what are causal systems and non-causal systems. So I think this may be the last lecture of this module number 1, and in which we are taking about classification of signals and systems, and then we'll go for LTI systems. So let's get started. We'll start with our today's topic, and first topic we'll deal with, that is our static and dynamic system. Static and dynamic system. Okay, so what are these type of system? See, the name suggests static means the system will be static in nature, and dynamic which will be dynamic in nature. So static suddenly means where there is no memory. Okay, there is no memory. That type of systems are called as static. And which systems which are having some kind of memory in it, some memory, so those type of systems will be called as dynamic system. Like if you see in terms of the components are there, electronic components, resistor, inductor, capacitor. So we'll see resistor can be called as static system, because the resistor doesn't have any type of storing element. But you see capacitor and inductor, it has some it stores magnetic field, it stores electric field, so it is storing something, so it can be called as dynamic system. Okay, and what are the other names which can be these systems can be called as? See, static systems are also called as memoryless system because it has no memory, and it is also called as instantaneous system. Instantaneous type of systems. Okay, so if you were asked what is dynamic system and what is instantaneous system, you should understand that it is talking about the static system. Okay, so how we can judge it? See, some systems I'll tell you, yt is equal to, let's suppose, 2 into xt. So by seeing this system you can understand that input is actually xt. Okay, and it is doing only multiplication, so nothing more than that, nothing storing element is there, so this system will be called as static. Let's suppose one more system will take yt is equal to log of xt, log of xt. So you can understand this system is taking input as xt, and it is doing just log of whatever input is there. So is it storing something? Is it storing something? No, it is not storing something. It is a static system. Again, one more example. If you see 2xt plus 3, if we will do 2xt plus 3, then also it is not storing anything, so it will be a static system only. But now we'll take some other example. Yt is equal to x of t into x of t minus 2. Now there is something, what yt is dependent upon xt, okay, no problem, but yt is dependent upon xt minus 2 means there it is dependent upon past value. Wherever the system is dependent upon some past value or some future value, it means if it is like, see, I gave earlier example also, like cricket match, recorded match is there, CD player is there. CD, if we insert it, so we are watching now at a moment the match, we can means we can go backward also, and we can see 2 minutes before match also. The point was what was the point, we can rewind it, actually we can rewind it, no problem in that. But that system is actually storing the all part. That's why we can rewind it now. So that is the thing, that it is storing something, and wherever it is storing something, that system is called as dynamic system. So this system is called as dynamic system. You need to remember it. Okay, let's suppose one more example we'll take. So now this system, see this system, what it is doing, whenever input is going on xt, it is integrating it from minus infinite to infinite. Means whatever xt will be there, it will integrate the values from minus infinite to infinite. Means somewhere, if it is adding something, it should have some memory, na? Then only it will add and it will keep it. See, if it is dependent upon present value, it cannot add. If it is storing some value, then only it is adding, na? Means from minus infinite the values are added and then output is coming. So ultimately these values were being stored somewhere. So that is why yt is dependent upon the storing element, and that is why this type of systems are called as dynamic systems. Okay. Okay, so I think you have understood what are static and dynamic system. It is not of very much concern, because by seeing the expression or understanding the nature of system, you can tell it is a static or dynamic system. Now we'll see some other type of system, like what are stable and unstable system. So stable and unstable unstable systems. Okay, fine. So what are these type of systems? Actually, for stable and unstable system, we are talking about BIBO system, BIBO stability system. BIBO stability, we talk about BIBO stability. So what is BIBO stability? BIBO stability means bounded input, bounded output system. So what is this type of system? Bounded input, bounded output. See, there is a input to a system. Okay, there is an input to a system and there is a output for that. Let's suppose xt is the input and yt is the output. Okay, so see, if at all, if our xt will be bounded, I told you earlier also, bounded and unbounded signals. Whenever we say bounded, means it is a amplitude bounded. Okay, so amplitude bounded means if our xt is bounded signal, means if we take its magnitude, it will be always finite. Okay, it will be equal to finite or less than finite. It is very finite value. Okay, so for a bounded input, if we are getting output as bounded, then this system will be called as BIBO stable system. BIBO stable system. Okay, simple concept. It is not of very difficult. I am telling you. See, if I'll tell you, I think I'll tell you one example. See, this type of signal you'll take. Let's suppose some values are there, but you can see this signal. It is, I think, bounded somewhere. Its amplitude is bounded. It is not going like this. It is not going like this. It is unbounded signal. So this is bounded. For this type of signal, if our output is also, let's suppose maybe output is like this. Okay, so so maybe this is also bounded. Somewhere it is bounded. So if at all, for a bounded input, if you are getting output as bounded only, then that system will be called as bounded input, bounded output stable system. So let's check by seeing some questions. Okay, so by seeing some questions, we'll check question number 1. Let's suppose we have seen so many systems in past also. So 2xt plus 7 is there. Let's see it is a stable or unstable. See, if your see yt is dependent upon 2 xt and 7, these all are constant. If yt is dependent upon xt and xt is if finite bounded, then definitely yt will also be bounded. So this type of systems will be called as stable systems. Now we'll see some more questions like yt is equal to, let's suppose x square t is there. Okay, now what is happening, actually you are giving input xt and system is doing square and you are getting output as yt is equal to x square t. If you say if your xt is bounded, if your xt is bounded, then obviously like xt is bounded means let its value is 5, so 5 square 25. So ultimately some value will be there, it is not an infinite value, some value will be there. And if it is unbounded, then though yt will be unbounded, no problem. But what we are condition we are checking, if if xt is bounded and then yt is giving output as bounded, then it is the system will be your Vivek stable system. Okay, let's see some more example. This system is there, let's suppose this type of system is there. Okay, and we are giving input as xt and we are taking output as, let's suppose x of 80 is their output. Okay, let's suppose output is xt minus t naught, output is coming. Let's suppose x of minus t is coming. Let's suppose x of t square, output is coming. So many systems I am seeing, I am telling you. Input your xt. So if your input is bounded, then obviously x of 80 will be bounded, weather will shift also, that is also bounded, this is also bounded, this is also bounded, everything is bounded, so it is a stable system. But and now let's check one more value. Let's suppose xt you have given input and you are getting output at to the power xt. So if at all your xt will be bounded, if at all xt is bounded signal, then e to the power, let's suppose xt is something 2 value, yeah 3 value something, so e to the power through 2 value, some value will come na, it is not an infinite value, some value will come. So this systems is also stable system. But now I will tell you some more example. Again we'll take input, okay, and this is output, this is input xt, and we are getting with a system we are getting some output is equal to some output we are getting. What output? I'll tell you, t into xt. Now you check, or yt is equal to let's suppose e to the power I think let's suppose x of t minus 2. Okay, okay, and let's suppose t minus 2 is also there. Now let's check. See, if at all your xt is bounded, if at all xt is bounded, but yt is dependent upon t also, so t may be something. Okay, let's suppose this value is 2 and t value is something infinite, like maybe it is infinite. Okay, so if it is infinite but xt is bounded, so ultimately yt will coming infinite only na. So for a finite input, for a bounded input, you are getting unbounded, you may get unbounded output. So this type of systems will be unstable system. Now you can understand that whatever, if yt is directly proportional to only xt, if it is only proportional to xt, then it is a stable system only, no problem. But something is multiplied in it, especially t values are there, if it is multiplied, then you can say it is a unbounded signal. See, this is also yt is equal to e to the power xt minus 2. Let's suppose your xt is bounded signal, so e to the power xt minus 2 will be also bounded, but here t minus 2 is there. So if t is tending to, let's suppose minus infinite value, okay, some values are there, so for this value also this signal will be this system will be unstable system, because somewhere it is not only dependent upon x, it is also dependent upon some other time factor also. So see, now we'll see another question. One more question is there. If you have been asked why t is equal to minus infinite to t x of t dt, this question is there. Now we have to check if it is a bounded or unbounded. See, let's suppose your xt is bounded. Let's suppose this is your xt signal is there, and this is bounded signal. No problem, you have fed it in a system and we will get some output. Okay, what output we'll get? We'll get see some output like we'll get output as minus infinite to t xt dt. So see, xt is bounded, maybe its value is 1. Let's suppose the value is 1. So here minus infinite to t 1 dt, we are doing integration of from minus infinite to t some values 1 we are doing minus infinite to I think okay, minus infinite to t we can do some integration. So some value will come. Okay, some value will come, and it may be your bounded, but if it is going on minus infinite to infinite xt dt, so it will be unbounded because its value will not come. Its value will be going to infinite value only. Whether your xt is bounded, no problem, but the value of integration maybe, see, if it is minus infinite to t, some values are there, then we can think of it will be a finite value. But if integration is minus infinite to infinite, the value will be infinite only, and there the system will be unbounded system. So now we'll go with our last system, last classification. Okay, so we'll see next classification as invertible system and non-invertible system. What are these type of systems? Okay, invertible, the name suggests invertible, and non, which can be inverted, that is invertible, which cannot be inverted, that is non-invertible. Simple concept. Okay, we'll understand it more better way. See, if a signal has been given to a system, okay, if a signal is given to a system, let's suppose this system is there S, okay, and if input is given xt and it is generating a output yt, and when this system or when this output will be given to some other type of system, okay, and if it is producing, if the condition is, see, again we will repeat, a signal is given input to a system, if it is producing output as yt, and if this output is given as an input to another system, let's suppose si is there, and this system is producing input as this system is producing output as xt, which is same as here, then this system, okay, then this system will be called as inverse system, and this system will be called as invertible system. Simple concept, no more than that. Okay, if I'll tell you in words, a system which is capable of producing input again is invertible system. Or you can see best example when you will see communication, will study communication systems, we will see equalizer. So in equalizer also there is invertible system, we use invertible. So SI, actually this SI is there, it is exactly doing the inverse job of the system. Means if this system is there, it is doing the inverse job, and this system is called as inverse system. And if it is possible to define an inverse system for a given system, if it is possible to define an inverse system, then that system will be called as invertible system. मतलब in Hindi if I say किसी भी system का अगर inverse system बनाया जा सकता है, तब उस system को हम invertible system कहते हैं. Okay, Okay, so we'll see some questions, we'll understand how we can judge it. So we'll see one question is there. Okay, see, yt is there, yt, let's suppose 2 into xt is given. Okay, so what we can do is we need to understand if input is given here xt, what it is doing, it is multiplying 2, so we are getting output as 2 of xt, this output is getting. Can we give this output to a as an input to a system? uh, so one system is there, let's suppose if one system is there, what it does, it multiplies with half. So whatever input is there, it will multiply half. So 2xt, if it comes, it will produce xt. So okay, this xt is same as this xt, it means this system is inverse system. So if at all, if anyone asks you what is the inverse system of this, you will tell half of xt. Okay, yt is equal to half of xt, this is the inverse system of this. Okay, so and this system is called as invertible system. Very easy, very easy, no problem in that. Okay, so I think okay, now we'll see one more type of system, one more. See, uh, like integration, yt is equal to integration of minus infinite to t x of t dt. This type of system is there. Now we'll check whether it is invertible or not. First we'll understand what this system is doing. If you are giving xt as input, and it is doing integration, whatever input is coming, it is doing integration of input. Okay, so we are getting as minus infinite to t xt dt, we are getting output as like this. If we are feeding it to a differentiator d by dt, we'll get as obviously we'll get as again xt only. So this is your inverse system, and this system is called as invertible system. But this is not true for every question. Like, see, one more question we'll see. Okay, so the question is yt is equal to x square of t. This question is there. Now see, input is there x of t, and you are getting some output y of t. What output you are getting? This system is doing squaring. Okay, so we are getting x square of t. Now if we'll take a system, we'll give this as an input. What we need to do, we'll need to do square under root. Okay, square rooting. So if you will get square root, then you can get two answers. What two answer? You can get plus x of t and minus x of t, because both of if you do square, you will get the value like this, x square t only. Okay, so here output can be anything. So this system is non-invertible system because it is not producing unique output. Okay, this is not producing unique output, that is why this system is called as non-invertible system. This also point you need to remember, it should produce unique output. Like one more question we can discuss, like see, yt is equal to cos of x of t. Okay, so now you'll see this system is there, x of t you are giving, it is what it is doing, just cos of input. So we are getting cos of x of t. If we are taking some system and system some cos inverse, you must be thinking that you will get xt, but we won't get exactly same unique xt, because see, if you'll give one as an input, cos 1, what you will get, cos of 1, you will get some of the values like see, cos of 1, maybe cos of 1. Okay, see, cos inverse of 1, if you will take cos inverse of 1, what we will get, cos inverse 1, 2 pi, 4 pi, 6 pi, very different values will come. Cos of 6 pi, cos inverse of 6 pi will also be 1, cos inverse of 4 pi will also be 1, cos inverse 2 pi will also be 1. So there is no unique value. Actually, there is no unique value which can be designed. So response should be unique. That is why this system is also non-invertible system. So the case you should remember is that if more than one input generates same output, okay, then that system is non-invertible system. Okay, so see here also y t is equal to x square t. More than one output, more than one input can generate same output, like plus of x t, if you do square, then also x square t will come. For minus of x t, okay, if we'll do square, then also x square t will come. So whenever more than one input will produce same output, like here cos of xt is there. So see, many value of xt of will do cos will get same response. So if many input is producing same output, then that system will be obviously non-invertible system, है ना? And one more condition is that whenever a system response becomes zero for non-zero input, like see 2xt was there plus 3 will be there. Let's suppose see, what we'll do xt will get input, okay. I think maybe chalo we'll give this as an input, okay. Why we can give dc value plus scale will give this value will give input to a system. Let's suppose differentiator we are giving input. So see 2xt plus 3, what will be output? You will get 2. I will tell you 4xt plus 3 to this system. You will tell no, I think 2xt plus 5. 2xt plus 5, if I will tell you, you will tell answer is 2. I will tell you 2xt plus 7, you will tell answer is 2. So more than one input, if it is producing the same output, it will be non-invertible system. You should remember it, okay. So this is the part which I need to tell you, okay. So I needed to tell you, and now I think all the systems I have covered, and this comes to the end of module 1. We have covered almost classification of signals and classifications of systems, and I am hoping that after seeing these videos, you will be able to solve many type of questions which are related to classification of signals and systems. And you may ask questions in the comment section. As soon as possible I'll get it, I'll reply it. And okay, so we'll meet in the next lecture and we'll see some more type of some LTI systems. We'll see how output response are taken, how convolution happens for discrete time system, for continuous time systems, for complex valued signals and all. So we'll meet in the next lecture with next module. Till then, tata, bye bye, see you, have a good day, and keep supporting us, keep motivating us. Write your feedback in the comment section so that we can get your feedback, it is going smooth or not. And our plan is to complete the GATE syllabus within the stipulated time period, so that you should get thorough of it. And it is a free class initiative by TEQIP faculty, so keep motivating us, okay. Till then, tata, bye bye, see you, have a good day, jai hind.